Etna has cycled through eruptions and pauses, becoming both a research site and a major attraction. That appeal comes with a sober reality. Beauty and danger share the same slope. Etna's behavior does not follow one simple script. It moves along a spectrum, from modest Strombolian pops and ash puffs to short, intense episodes that fling columns of molten rock skyward. In the latest chapter, fresh lava has again threaded down the flanks, cutting glowing rivers through black scoria, while orange fountains light the night. Authorities tightened access, keeping people below roughly 8,200 feet, about 2,500 meters, while instruments flagged elevated shaking. The goal is straightforward: admire the show, but keep distance while the mountain's pulse is high. A new feature has become the focal point of concern, a visible fissure on the upper slope. Drone surveys and handheld footage make the crack unmistakable. This is not a surface blemish. Fractures like this reflect underground stress as pressurized magma pries rock apart. Such openings can precede larger events, lateral eruptions lower on the cone, or, in more severe cases, structural slumps that peel away portions of the flank. Scientists have long measured a slow, persistent slide of parts of Etna seaward, a creep that usually proceeds at a walking pace each year, but hints at the forces at work inside the edifice. In rare cases elsewhere, sudden volcanic slope failures have even kicked up waves. That is not a forecast for Sicily, but it explains why a new crack instantly raises the stakes for monitoring. Even as lava fountains and glowing streams seize the eye, the volcano's internal heartbeat, the tremor signal, continues. It strengthens and dips, but together with surface deformation, it points to a system under pressure. Volcanologists are asking a simple question with complicated implications. Is this a familiar pulse in Etna's rhythm, or the start of a deeper reshaping of the mountain's plumbing and flanks? The fracture sits just below the summit crater complex, in what specialists call a subterminal zone, near the 3,000-meter contour. That belt is notorious among Etna watchers, because stress can accumulate there until the volcano chooses a side vent instead of the summit. Flank eruptions are disruptive. They can open abruptly, cross trails and roads, and send lava toward valleys long unused to flows. Their unpredictability raises risk for hikers, workers, and nearby communities alike. Ground sensors show deformation consistent with magma intrusion, hot material wedging into cracks and lifting the surface. Biomount satellites detect even when people notice nothing. The new fissure is likely the surface expression of that push. If intrusion continues, modest activity can escalate into stronger paroxysms, or if rock fails, into local collapses. Recent aerial passes mapped several small vents feeding multiple lava tongues. As they descended, the flows split and rejoined like braids in a river. The farthest fronts reached about 7,546 feet, around 2,300 meters. Higher up, the summit vents above, roughly 9,843 feet, near 3,000 meters, continued to supply fresh magma, turning the upper slopes into a moving assembly line of incandescent rock. In parallel, Italian civil protection raised the alert posture. An F1 advisory signals heightened caution and keeps the summit effectively off limits. Should conditions escalate to an F2 stance, as happened earlier this season, authorities would warn about fast-moving hot clouds and sudden hazards. A recent dip in seismic chatter may look like relief, but lulls on Etna often precede bursts. Paroxysmal episodes, sudden violent releases of pressure, can drive sky-high lava jets, loft-tall ash plumes, and blast glowing clasts across wide arcs. Those clasts, called lapilli volcanic bombs, can be as small as gravel or as large as a football, and they travel fast. On busy volcanoes worldwide, people have been injured by projectiles and ash clouds that outran expectations. A grim lesson from New Zealand's Wakari/White Island is that a volcano in routine activity can still switch gears without much warning. Etna is more active than most, so that lesson applies doubly here. Part of the management challenge is Etna's shape-shifting tempo. A cycle can start with tame spattering, leap into fountains, toss short-lived pyroclastic surges, then fall back to a simmer. The newly mapped fracture could mark a deviation from that familiar arc, hinting that structural stress is accumulating in a way that increases the odds of a lateral opening. Italy's National Institute of Geophysics and Volcanology reports ongoing Strombolian bursts at the summit with intermittent ash visible from surrounding towns. Analysts watch more than camera images. They track the precise height of advancing lava fronts, monitor the rise and fall of harmonic tremor, and listen for infrasound signatures that reveal explosions even when weather hides the vents. Together, those metrics show magma still moving underground and feeding the surface. Because the system is unsettled, caution is wise. No one can say with confidence how the next day or two will unfold, and that uncertainty is itself a warning sign. Persistent tremor, active deformation, a fresh fissure, and multiple lava sources argue for restraint on the mountain and vigilance in the communities below. A new vent can open with little notice. An existing vent can choke and then clear with more force. Wind can swing an ash plume over a road that was clear an hour earlier. Sicilians have lived with that reality for generations. Ash on the windshield at breakfast and a faint glow on the horizon after sunset are part of the local rhythm. When instruments show rising risk, authorities close trails and restrict access. The latest fracture, together with pressure signals, argues for a stretch of heightened respect. Being prepared, knowing routes, keeping masks, having a communication plan is not alarmist. It is responsible. Round-the-clock monitoring continues. Networks of seismometers listen for swarms, too small for people to feel. GPS receivers and tilt meters register millimeter-scale motions of the ground. Thermal cameras chart the heat of flows and vents. Gas sensors measure sulfur dioxide and other emissions that rise when new magma nears the surface. Drones supply overhead views that ground teams cannot get safely. Together, these tools give a near real-time portrait of Etna's mood and help officials adjust closures and guidance. The broader scientific community follows closely because each Etna cycle teaches lessons that travel. Comparing data from Sicily with other regions sharpens models of magma ascent, flank stability, and the thresholds that tip a photogenic eruption into a hazardous one. In that sense, every measurement taken on Etna contributes to the global understanding of how our planet moves heat and material from its depths to the surface. For visitors and locals, the advice remains simple. Enjoy the spectacle from safe lookouts and respect guidance from the park and civil protection. Keep clear of summit zones. While the alert is elevated, the mountain's beauty is real, and so is its unpredictability. Respecting both is how you witness the show, without becoming part of the response. If you're passionate about geology and want more updates as this sequence evolves, stay tuned. We'll keep translating measurements and field notes into plain language. It's starting to feel like mountains everywhere are loosening at the seams. If you've been tracking the recent run of rockfalls and slope failures, you're not alone. Share your take below on what this means for mountain belts and their valleys worldwide. Let's focus on one case study, Hochvogel, rising to roughly 8,500 feet, 2,592 meters. It stands apart in the eastern Algae Alps on the Bavaria-Tyrol line, a solitary summit that dominates lower neighbors. Long before official records caught up in 1818, local shepherds were already on its ridges. Surveyors later used the peak as a triangulation point during early mapping efforts, proof of how prominent and reliable a landmark it once seemed. That appearance of permanence hides a touchy geology. Hochvogel is built mostly of Maine dolomite, a Triassic-age sedimentary rock. It's tough on the whole, but under the right stress, water, and temperature conditions, it can fracture and fail. History bears that out. On May 27, 1935, a massive failure ripped from the southwest face, sending thousands of cubic yards, thousands of cubic meters of rock downslope. More modest slips followed in 2005, 2007, and 2016. In other words, instability here isn't new. What's changed is the pace and scale of warning signs. The headline issued today is a summit-spanning crack that has been widening and deepening. Earlier measurements described a fissure about 130 feet, 40 meters long, approximately 10 feet, 3 meters wide, and approximately 26 feet, 8 meters deep. By 2024, high-resolution monitoring indicated dimensions on the order of 115 feet, 35 meters, in length, nearly 20 feet, 6 meters across, and roughly 20 feet, 6 meters deep. If a major section lets go, estimates suggest as much as approximately 340,000 cubic yards, approximately 260,000 cubic meters of rock could detach. Enough volume to reshape a valley floor and strip trails, alpine meadows, and infrastructure in its path. Since 2014, geoscientists and engineers, principally from the Technical University of Munich, and the GFZ Research Center in Potsdam have run an advanced warning network known as AlpSense Bench. Think of it as a digital nervous system for the mountain. Laser scanners, geophones, crack meters, GPS, and a continually updated 3D twin-track tiny movements down to hundredths of an inch, tenths of a millimeter. The system's goal isn't fortune-telling, it's pattern recognition. When motion accelerates in ways that typically precede failure, the instruments can flag danger a couple of days in advance. Like a weather forecast, it can detect trends and tipping behavior, but it cannot name the exact hour a block will break. Despite the warnings, curiosity draws people in. Hikers still edge toward the open fracture to see the problem up close. That uneasy mix, spectacle and risk, has turned Hochvogel from an icon of alpine beauty into a live hazard zone and one of the most closely watched mountains in the range. Seasonal conditions amplify the threat. As European summers warm, accelerated snowmelt and heavier rain load the rock mass with water. Rain infiltrates joints and bedding planes, acting like a lubricant, while also adding weight. Over the past 5 years, the crack's width has grown by about a foot, approximately 30 centimeters. A small number on paper, but alarming at this scale. The situation echoes a Swiss case near Blatten, where a slope's movement rate jumped from approximately 0.5 inch per day to approximately 0.5 inch per hour, an escalation that made collapse imminent. That is exactly the kind of acceleration the sensors here are tuned to catch. If a major release occurs, modeling suggests debris could surge into Austria's Hornbach Valley near the Germany border. Population in the direct path is sparse, but there are well-used trails, huts, and grazing areas. The consequences for those sites could be severe, even if towns farther away remain out of reach. To manage that risk, authorities have tightened early warning procedures so that rescue teams, alpine clubs, and local administrations on both sides of the frontier receive immediate alerts. With even 2 days' notice, priority areas could be cleared to prevent casualties. One event may not be the end of it. Specialists expect a stepwise breakdown is possible. Phases of failure spread over months or years. That kind of drawn-out destabilization would keep access limited and require continuous monitoring, with ripple effects for tourism and the local economy tied to mountaineering and hut networks. There's also the human layer. For communities that have lived with the mountain as a backdrop, a place of quiet and challenge, the present uncertainty carries a psychological toll. Trails that once felt routine now demand vigilance. The landscape itself feels provisional. Zooming out, Hochvogel's behavior fits a pattern seen across the Alps. In recent decades, extreme weather has become more frequent. Intense rain, hotter summers, and volatile storms. Lightning is under investigation too. Repeated electrical strikes can micro-damage rock, and when you combine that with prolonged saturation from rain, the structural integrity of fractured dolomite can degrade over time. It's death by 1,000 cuts. No single factor explains it, but together they tip the balance. Monitoring continues around the clock. Millimeters matter here. A slight jump in displacement speed can separate stable enough for now from failure in progress. And the hazard isn't only rockfall. Should a large collapse occur, secondary debris or mud flows could mobilize later, potentially traveling into the Hinterbach Valley and creating follow-on dangers. That's why planners are already sketching longer-term protections, not just emergency responses. Add it all up, climate trends, the natural fatigue of an old mountain, human exposure, and the slow arithmetic of geology. And Hochvogel has become a working laboratory. It's no longer just a summit to photograph or bag. It's a case study in how fast solid ground can change. The old cliché, solid as a rock, doesn't land the way it used to when the rock is riddled with widening joints and measurable motion. What does feel solid is the need to respect both the landscape and the science watching over it. If stories like this catch your interest, stick around, subscribe, tap the bell so you don't miss new deep dives, and pass this along to friends who follow natural hazards. And tell us in the comments what you make of the Hochvogel situation, or if you've seen similar slope instabilities on your own travels. Your experiences help widen the discussion. For those who want a little more technical context, consider the mechanics at play. Main dolomite typically features bedding parallel weaknesses and vertical fractures, formed over geologic time. Freeze-thaw cycles widen those voids as water expands into ice, and in warmer seasons, infiltrating rain reduces friction along those same plains. Add the occasional seismic vibration, regional earthquakes, or even distant tremors can contribute, and you have a system primed for episodic movement. Each episode need not be catastrophic on its own, but cumulatively, they can reduce the safety margin until a nudge, an intense storm, a temperature swing, or a saturated week pushes the mass beyond its threshold. That is where monitoring earns its reputation. Laser scanners map the face repeatedly, comparing point clouds to detect subtle bulges or overhang growth. Geophones listen for microcracking, tiny acoustic emissions that hint at bonds failing within the rock mass. Crack meters measure aperture changes across the fissure, while GPS monuments track surface displacement. Feed all that into a living 3D model, and you can see which blocks are moving coherently and which are locked, giving responders a target for closures and evacuations that is grounded in data rather than guesswork. The goal is not to eliminate risk, no one can, but to convert uncertainty into informed decisions that save time and lives. The social piece matters too. Messaging must balance clarity and proportion, neither downplay nor sensationalize. Local guides, HUD operators, and municipal leaders succeed when communications are simple, timely, and consistent. Close today signs need clear detours. Alert levels should be color-coded and explained. Evacuation drills should be practiced in shoulder seasons when routes are less crowded. Small choices like multilingual notices or QR codes linking to live dashboards can save minutes when minutes matter, and visitors can help by treating closures as lines not to be crossed rather than challenges to brag about online. Finally, remember that mountains change on human timescales more often than we think. The Alps are not static museum pieces. They're dynamic landforms shaped by uplift, weathering, ice, water, and gravity. Hochvogel is a reminder that beauty and hazard live side by side. Respect the forecasts, heed the ropes, and treat that widening crack not as a spectacle, but as a message from the rock itself. As we wrap up, a quick note on personal responsibility. If you visit this area, plan conservatively. Check current closures, register your route when required. Carry a map and headlamp even on fair weather days, and turn around early if the ground or the forecast feels wrong. The summit will be there tomorrow. Your margin for error may not.